Okay, geometries, this is lesson 3.5, parallel lines and triangles. Our objectives today, okay, let's make sure we know what our objective is, to use parallel lines to prove a theorem about triangles, to find the measures of angles of triangles. So we're going to do two things today with that, and we're going to slide on, make sure you get that objective down. But our essential understanding here, as we step through so you know what's going on, the sum of the angle measures of a triangle is always the same. Now, through a point, not on a line, there's one point and only one line parallel to that given line. Let's try that reading again. Through a point, not on a line, there is one and only one line parallel to the given line. So if I have a line and I put a point out here, only one line will be parallel to the line that's provided that goes through that point. There's exactly one line through P parallel to L. Now, triangle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So when angle A, angle B, and angle C are all added together, they will always be 180 degrees. This proof requires the use of something we have never used before, an auxiliary line. An auxiliary line is a line that you add to a diagram to help explain relationships and proofs. The book will use a red line to denote an auxiliary line, okay, when we're doing this. So here, if I have a triangle and I provide a triangle, I'm going to put in something called an auxiliary line, okay. Now, let's talk about this proof. If I look this over, if I can bring that up at all, bring that down. There we go, got some extra space. And our proof of 310, triangle angle sum theorem. Well, the first thing is my given. So 1, triangle ABC is given, okay? Now, keeping in mind that triangle ABC is given, what I'm trying to show is that angle A, the measure of angle 2, and angle C are 180 degrees. Right now, I know that this next step, using and kind of do it rough, I know that I have angle 1 here, and angle 2 and angle 3 are going to make up 180 degrees. Okay, and I can do that through segment addition, angle addition postulate. Now we're going to do that through angle addition postulate. One of the things I want to make sure we realize is that angle addition postulate is about two angles being added together. So I'm going to use the fact that angle PBC and angle 3 are supplementary. Okay, and I can do that. I can say that angle PBC and angle 3 are supplementary because angles that form a linear pair are supplementary. Okay, so that's a linear pair postulate. Okay, now keeping that in mind, I know as I move on here that the measure of angle PBC, plus the measure of angle 3 is equal to 180 degrees. Now I'm not complete here because I'm going to use segment angle addition postulate and talk about the measure of angle PBC is also comprised of the measure of angle 1 plus the measure of angle 2. Okay, and I'm getting carried away here. I've got to fill in some steps. So let me fill in a couple steps here. This step is because of definition supplementary. Angles. And then this step that I just wrote is because of angle addition postulate. Let me get this a little smaller so you guys can see. And I have angle addition postulate. Angle addition postulate. Okay, and I'm going to get my diagram up a little higher so we can talk about that. there. Okay, now what have I done? I have taken, let me get my little point out here. I have taken the fact that angle PBC and angle 3, excuse me, I've got to get those back. Well, angle PBC, I've got a little pointer. PBC and angle 3 comprise of 180 degrees. PBC is made of two angles. Now, why am I doing that? Because now that I know that I have 1, angle 2, and 3, all three of these angles will add up to 180 degrees. That's what I'm going to do in my next line, okay? I will be able to substitute by alternate interiors and alternate interior gams the value of 1 in A and the value of 3 in angle C into my equations. So I can prove the measure of angle A and the measure of angle 2 and the measure of angle C are 180 degrees. Let's fix this and get this transparency fixed. And we'll do that too. We'll set transparency, got that made, so now we can move that around accordingly. Now, that's what I'm going to do. So 5, I know the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And I'm going to do that, and I know that because of substitution. Okay, now I know in step 6, I'm going to talk about angles, so I'm going to change colors. Step 6, I know angle 1 is congruent to angle A. Angle 1 and angle A are congruent, but for this auxiliary line that's drawn here is parallel to AC. Otherwise, this doesn't work, and when we draw on an auxiliary line, we make it work for what we need it. Okay, so I know 1 and A are congruent because of that parallel line. I also, for that same reason, know that the angle 3 is congruent to angle C. Angle 3 is congruent to angle C. Gosh, everything's kind of going crazy right now. Sorry, guys. Okay, there we go. Hopefully this will catch up for everybody. Okay, and this is because of alternate interior angles theorem. Okay, so I know that. Now, keeping in mind, I know that these angles are congruent, and I've got to use them in equality. So I've got to bring them down from congruence to equality so I can put them in an equation. So I know the measure of angle 1 is equal to the measure of angle A, and I know the measure of angle 3 is equal to the measure of angle C by definition of congruence. Now, after I do that, I can now substitute. Where I see A here, I can substitute A in there, and I can substitute, let's get some black here, where I see 3, C. So that's what I'm going to do in my next step. So here comes my substitution step, and I've got 8. This is my substitution step. And I'm going to say, okay, I know that the measure of angle A plus the measure of angle 2 plus the measure of angle C is all equal to 180 degrees, and that's by substitution. And that's property of equality. And that's what I was asked to prove at the beginning of all this. So let me get this squeezed down a little bit so we can all see that. Well, maybe not. Maybe we can see that. But that's what I was asked to do. Okay? You know, measure of angle A plus the measure of angle 2 plus the measure of angle C is 180. And that's what we are able to prove. Okay? So that's proving triangle sum theorem. So now let's use it. Using the triangle angle sum theorem, what are the values of x and y in the diagram at the right? Well, I know this first triangle, triangle ABD. So let's work with triangle ABD. Okay, I know that 43 plus x plus 59 is equal to 180. Okay, so keeping that in mind, I've got 43 plus 59. Okay, let's put that mode. 43 plus 59, and that's going to be 102. So I got 102 plus x equals 180. I'm going to subtract and find out that x is 78. Okay, now that is for my triangle ABD. Okay, so we're going to group that in so I can make some space here. Now, in my other triangle, my triangle BCD, my triangle BCD, I'm going to do some other stuff. But now, wait a minute. I only have the fact that I'm looking at 49 plus y plus z. How can I get y? Well, I know that x is 78. Okay, and I know 78 plus y is equal to 180 in that relationship. So I know y is 102 degrees. So with that said, I've got 49 plus my 102 from using that x and y are supplementary angles and they're a linear pair. And then I can say with the plus z, and that's going to equal 180. So now I've got 151 plus z is equal to 180, and I know that z is 29 degrees. Okay, so I've got my x, I got my z, and I got my y, so I was able to find everything. So I've got x is equal to 78, y is equal to 102, and z was equal to 29. Now, use the diagram in problem 1. What's the value of z? Gosh, we found z. It's right there. Now, an extension to the triangle angle sum theorem is the triangle exterior angle theorem. The measures of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So these two add together to be that angle. Okay, now using the triangle exterior angle theorem, the measure of angle 1 is equal to 80 plus 18. So that equals 98 degrees. Now let's just think about what's going on with that, because I want to make sure you know that I'm saying angle 1 is 98. Okay, so we're going to make sure that we understand that, and let's check out this idea this way. I know that that's the exterior angle. This and that are remote interiors. So 124 is equal to 59 plus the measure of angle 2. So I'm going to take my 124, okay, 124, subtract 59, okay, and that's going to be 65. So 65 is equal to my measure of angle 2. Now, two angles of a triangle measure 53 degrees. What's the measure of an exterior angle at each vertex of the triangle? So right now, two measures, and this is just 53, this is 53. So remember, there's an exterior angle, 1 at each vertex. So 180 minus 53 gives me 127. And so this is also 127. But remember, that's 106 degrees. So I know that this is 106 because this and this are my remote interiors. That's my exterior angle, my 106. 53 plus 53 is equal to that. Now, I subtract 180 from 180, my 106, and I get 74 degrees, and that should be 74. So that's what we're doing with finding our values here when we're working around. So what's the measure of the exterior angle at each vertex? And this is what we're asked to find. Multiple choice: when radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there's a radar receiver at A, an airplane at B, and an airplane ghost at D. What's the value of X? Okay, so really what I'm asking for is I've got to find that that's 80. So I subtract 180 minus 80, and I get that this is 100. Okay, now I can work it this way with my triangle and go 30 plus 100 and know this is 50. Or I could go, well, 80 is an exterior angle, and that is equal to 30 plus x, and subtract and find out that x is 50. So x is 50 degrees when we're doing that. And that's our summary. Our objectives: to use parallel lines to prove a theorem about triangles, to find measures of angles of triangles. Now go ahead to the inside part of your front page and mark out what you know. Have a great day.